Modeling data using exponential equations. Part 4. Modeling data for exponential functions pretty much the same as what you did with polynomial functions. If you can't remember, you may want to look back at that or to your instructions for graphing regression equations in the resource section of the website. What you're going to be looking for is one that says EXPREG for exponential regression. Okay? All right, so just have a couple of examples of this and you'll be on your way. So, we have Emma dealing with some water that's cooling off. She placed a volume of hot water in a cup and recorded the temperature of the water as it cooled over time. Her data is given in the table. Construct a scatter plot to display Emma's data, then determine the equation of the exponential regression function that models the data. Okay, so on the x-axis, I made every one 5. So that would be 10, 20, 30, 40, and 50. Sorry, I didn't leave you a lot of space there. Okay, and this is going to be time in minutes, which means the temperature goes on the y-axis in degrees Celsius. Okay, and you should also have a title. We'll just call this Emma's data. Okay, I'm going to use every line is worth 10 on the y-axis. So 20, 40, 60, 80, and 100. Okay. So let's start plotting some points here. Okay, when time is 0, temperature is 90. So 0, 90. After 5 minutes, we're at 78, so roughly there. Okay. After 10 minutes, we're at 68, so roughly there. After 20 minutes, we are at 52, so about there. And 30 minutes, we're at 38. Okay, and 45 minutes, we're down to 26 degrees. So that'd be right about there. Okay, notice the nice curving nature here. And we can connect these dots. Okay, because time, you can have like parts of time and you can have parts of temperature. So the domain here is real and so is the range. Okay, now the exponential regression equation. So again, you want to go in and if you are in 84, this information goes into L1 and this goes into L2. If you're in Inspire, then of course you have your two columns. In column A, you're going to put time. So you might label that M for minutes. And in column B, C for Celsius for your temperature because they both start with T. Okay, and then put that data in there and find your regression equation. Remember, you're looking for one that says EXPREG. Okay, if you want to pause the video while you want to type that in, when you unpause the video, you will find the equation in the form y equals a times b to the x. Okay, and that a is 89.7 and that b is 0.973 all to the power of x. Now, if you notice my base is less than 1 and you take a look at your graph, you notice that it is a decreasing graph. That obviously makes sense based on the value of b. Okay, describe the characteristics of the exponential function. So, there is no x-intercept, as usual. Okay, the y-intercept is about 90. So A is 89.7, so about 90 degrees Celsius. Okay. The end behavior, we're starting on the y-axis, and we're moving into quadrant 1. Okay. The domain is x is greater than or equal to 0. X belongs to real, because again, time cannot be negative. And the range is y is between 0 and 90 degrees. Awesome. At what time to the nearest minute did the water reach 51 degrees Celsius in Emma's experiment? So what you can do there is temperature is a y value. So go to your graph in y1, type in 51 degrees Celsius. Well, I'll just type in 51, I guess. Okay. And then you want to figure out the intersection of your graph, your exponential regression equation, with y equals 51. Okay? Good. I found it to be at a time of 21 and about 3/4, 0.74 minutes. So that's how long it took for the temperature to reach 51 degrees. Okay, that's that example. Let's try the next page. Number 2. 4 years ago, the Bellons retired and moved into an apartment. Their annual rent for 4 years is given in the table. Determine if the data can be represented by an exponential model. Explain. Okay, so if it were linear, then as this goes up by a constant amount, this should change by a constant amount as well. So this goes up by 1, this goes up by 360. Okay, this goes up by 1. This one goes up by 384. So we can see that it's not going up by a constant amount, so it's definitely not linear. That goes up by 1, that went up by 408. Okay, so definitely not linear, so it's possible that this can be an exponential model because x is increasing by an amount each time rather than going up by a constant amount, okay? So the rent is not increasing by a constant amount each year, but an increasing amount compared to the previous year. So yes. Okay, so maybe exponential. Okay, determine a regression equation to model the data. What is the rate of increase? So again, you want to type your years since retirement because time is always independent, okay? And your rent depends on how many years have gone by. So that's your L2, or again, if you have an Inspire, okay, then years goes in column A and rent goes in column B. And you're looking for an exponential regression equation. It'll come in the form of y equals a times b to the x. So please press pause until you have your regression equation. Okay, so the equation I got was a was 95.43. And again, that should be really close to the value that they have when x is 0 because it's a line of approximate fit, best fit, right? But not a line of exact fit. So it should be pretty close. Okay, times 1.0385 to the power of x. Okay, now to find our rate of increase, okay, this is our multiplier. Now, if we were to change that into a percentage, that would be 103.85%. Okay, well, we want to subtract 100% because that would be what would happen if it didn't change. So the rate of increase is 3.85% each year. Okay? Part C, assuming the same rate of increase, predict what the Bellons will pay in 10 years. Round answer to the nearest dollar. So what we can do is years is an x value, so I can just substitute 10 in for x in this equation. So y equals 95.43, because again, we're dealing with money, we should round to 2 decimal places, times 1.0385 to the power of 10. Okay, I've got, and it says the nearest dollar, So that would be $14,001. Okay, awesome. So they will be paying a fair amount of annual rent after 10 years, but hey, that's all what inflation does. Okay, so page 377 is where you're headed. You have to do question 1, and anything between 4 and 16. You could do 4 or 16, okay, but you have to pick 4 of them between there. And again, show your work to your teacher when you're finished.